In this video, I'm overclocking the Intel Core Ultra 9 285K all the way up to 5716 MHz using the ASUS ROG Maximus Z890 Apex motherboard and custom loop water cooling. I'll speedrun you through the BIOS settings and provide some notes and tips along the way. Please note that this is for entertainment purposes only and not the whole picture. Don't just outright copy these settings and apply them to your CPU. If you want to learn how to overclock the 285K, have a look at the longer SkatterBencher guide that's already up on this channel. Alright, let's do this. When you've entered the BIOS, go to the Extreme Tweaker menu. Set Performance Preferences to ASUS Advanced OC Profile. This configures a number of BIOS options that help with overclocking. Set AI Overclock Tuner to XMP1. This lets us rely on the Intel Extreme Memory Profile 3.0 technology and will make our memory run at its rated speed of DDR5 8400. Set ASUS Multicore Enhancement to Enable to remove all limits. This unleashes the Turbo Boost 2.0 power limits and lets the CPU run at unlimited power indefinitely. Set Performance Core Ratio to Bi-Core Usage. This enables us to configure a dynamic P-core overclock, as we can define the maximum allowed P-core turbo ratio for a number of active P-cores. Set 1 core to 6 core ratio limit to 58. Set 7 and 8 core ratio limit to 56. Enter the specific performance core submenu. Here we can define a maximum allowed ratio for each P-core individually. Set Performance Core 0 to Core 5 specific ratio limit to 56.83. Set Performance Core 6 and Core 7 specific ratio limit to 57.16. Leave the specific performance core submenu. Set Efficient Core Ratio to Bi-Core Usage. This enables us to configure a dynamic E-core overclock, as we can define the maximum allowed E-core ratio for a specified number of active E-cores. Enter the By E-core Usage submenu. Set Efficient Turbo Ratio limit 1 to 53. Set Efficient Turbo Ratio cores 1 to 4. Set Efficient Turbo Ratio limit 2 to 52. Set Efficient Turbo Ratio cores 2 to 12. Set Efficient Turbo Ratio limit 3 to 50. Set Efficient Turbo Ratio cores 3 to 16. Leave the By E-core Usage submenu. Enter the Specific Efficient Core submenu. Here we can define a maximum allowed ratio for each E-core cluster individually. Set Efficient Core Group 0, Group 1 and Group 3 specific ratio limit to 53. Set Efficient Core Group 2 specific ratio limit to 54. Leave the Specific Efficient Core submenu. Set DRAM frequency to DDR5 8000. I had to do this because this particular kit was not stable at the rated XMP 8400 frequency. Enter the Thermal Velocity Boost submenu. Set TVB voltage optimizations to disabled. This prevents the CPU from automatically reducing the operating voltage when the CPU is operating at a lower temperature. Set overclocking TVB to enabled. This allows us to restrict the P-core and E-core turbo ratio depending on the CPU operating temperature. In our case, we want to restrict the P-cores to 55x when 7 or 8 P-cores are active and the operating temperature exceeds 70 degrees Celsius. Set OCTVB configuration limit to per P-core group. Set OCTVB ratio item mode to per core mode. Set 7 and 8 core active to enabled. For 7 and 8 core active, set temperature A to 70. For 7 and 8 core active, set a negative ratio offset A to 1. Leave the Thermal Velocity Boost submenu. Enter the Max Voltage Limits submenu. Intel has imposed strict voltage limits for their CPUs. We can increase this to plus 300 mV over the default maximum VID. Set E-core max voltage limits to 1.361. Leave the Max Voltage Limits submenu. Enter the Performance Core VF Point Offset submenu. Here we want to undervolt all P-cores at VF points 5 and 6, which are mapped to ratios 53x and 55x respectively. Furthermore, we increase the voltage for the non-favored P-cores at VF point 8, which maps to 57x. Set VF point present mode to per core mode. For Performance Core 0 to 5 VF point offset, set VF point 5 offset to -50, Set VF.6 offset to -15, and set VF.8 offset to +50. For performance core 6 and 7 VF point offset, set VF.5 offset to -50 and set VF.6 offset to -15. Leave the performance core VF point offset submenu. Enter the efficient core VF point offset submenu. Here we want to undervolt the E cores at VF.6, which maps to 46x. Set VF point present mode to all core mode, set VF point voltage control mode to manual mode, and set VF.6 offset to -75. Leave the efficient core VF point offset submenu. Enter the tweaker's paradise submenu. Set high D2D cold boot workaround to enabled. This helps fix some booting issues when the CPU D2D is overclocked. Leave the tweaker's paradise submenu. Set max CPU cache ratio to 42. That increases the ring frequency by 300 MHz from the default 3.9 GHz. Set NGU ratio to 34. That increases the NGU frequency by 800 MHz from the default 2.6 GHz. Set CPU D2D ratio to 38. That increases the CPU D2D frequency by 1.7 GHz from the default 2.1 GHz. Set performance core DLVR voltage to adaptive mode. That enables us to set an adaptive voltage mapped to each P-core's OC ratio, which is defined by the per-core ratio limit. Set additional turbo mode voltage to 0.6. That avoids any motherboard auto rules overriding our wish to rely on the fact-refused VF curve and the VF point undervolt. Set efficient core DLVR voltage to adaptive mode. That enables us to set an adaptive voltage mapped to each E-core cluster's OC ratio, which is defined by the per-core ratio limit. Set additional turbo mode voltage to 1.35. Set ring DLVR voltage to adaptive mode. That enables us to set an adaptive voltage mapped to the ring's OC ratio, which is defined by the ring ratio. Set additional turbo mode voltage to 1.2. Set CPU system agent voltage to manual mode. This dynamic voltage rail powers several parts of the SoC dielet, including the NGU, IMC, and NPU. By setting it to manual mode, we can set a static output voltage from the voltage regulator. Set CPU system agent voltage override to 1.3. Set VNN AON 0.77 volt voltage to manual mode. This static voltage rail powers several internal voltages, including the D2D interfaces. The VNN AON voltage is pretty important, typically serving as the floor voltage in power-saving scenarios. Set the VNN AON voltage override to 1.0, then save and exit the BIOS. We rerun some benchmarks to ensure everything is working as intended and check the performance increase compared to the default settings. Higher is better, and all of our benchmark scores are higher. The highest core clock reported in the operating system is 5716 MHz. When running the OCCT CPU SSE stability test, the average CPU P-core effective clock is 5419 MHz with 1.218 volts, and the average CPU E-core effective clock is 5000 MHz with 1.219 volts. The average CPU temperature is 103 degrees Celsius. The average CPU package power is 365.3 watts. And that's it. I want to thank the patrons and the YouTube members for the support, and see you next time.